Today we will be in Chapter 9, Section 2, Solving Systems of Equations by Substitution. Our topic objective for today will be to solve systems of equations by substitution. Okay, 9.2, Solving Systems of Equations by Substitution. Our goal for this section is to obtain one equation containing only one unknown. When you're looking at a system of equations, you have two equations, and each of those has two unknowns. So we're hoping to get down to one equation with one unknown. Now there's 5 steps on how you're going to work these problems. The steps sound a little bit confusing, but I'm going to work through a couple of examples to show you how to utilize these, and hopefully that will make the steps make more sense. So the first step is to solve one of the equations from our system for one variable. Then, for step 2, we will plug that into the other equation. Step 3, we will solve for the remaining variable. Step 4, we will take the solution from step 3 and we will plug it in to the equation from step 1, and then we will solve. Like I said, that sounds pretty confusing. Hopefully you will see how all these steps kind of intertwine and work together and be able to solve this. It's easiest through just doing some examples. So this is literally all 9.2 is just doing these. And so I'm going to work through a whole bunch of them, and then I'm not going to do any of your homework problems because that's really all we're doing today is just a whole bunch of homework problems. So I'm going to try and leave the steps up for as long as I possibly can so that you can be able to go through them. Okay, so here's our example. We have our system of equations. We have x plus 3y equals 18. And we have 2x plus y equals 11. So step 1 says to solve one equation for one of the variables. So I'm just going to start with the first equation. It's listed first, so I'm going to start with it. So we have x plus 3y equals 18. So I need to solve this equation for one of the variables. It doesn't matter which one, but my x is already kind of by itself. It doesn't have any coefficients out front, so I'm just going to solve for x. So that means I just subtract over my 3y. So that will leave me with x equals 18 minus 3y. That right there is step number 1. Step number 2 says we then need to plug this into our other equation. So our second equation says we have 2x plus y equals 11. So we just solved for x over here, so that means we need to take all of this stuff and we need to plug it in wherever there's an x in our second equation. So that means we have 2 times 18 minus 3y plus y equals 11. That's what step number 2 means. So we're taking all of this and plugging it in over here. Step 3 says we need to solve for the remaining variable. So now if you look, we have one equation with one variable, and that's our goal. That was our goal at the very beginning. So that's what we're going to do. So we have 2 times 18, which is 36, minus 6y plus y equals 11. So that'll give us a negative 5y. And if you subtract over your 36, it'll give you a negative 25. Divide both sides by a negative 5, and that gives you y equals a negative 5. Or excuse me, that's supposed to be positive. Positive 5. So we have y equals 5. So right now we know half of it. We know what y equals, but we don't know what x equals. So step 4 says we take this solution that we just got and we're going to plug it into the equation from step 1. That's this equation over here. The x equals 18 minus 3y. So now anywhere there's a y, we're going to plug in 5. Okay, so we're taking this right here, and we're going to plug it in over here. Lots of arrows. Lots of arrows. So that means we have x equals, and I'm going to rewrite it, 3 times 5. Wherever there was a y, I plugged in 5. So x equals 18 minus 15. X equals 3. So we have x equals 3, y equals 5. So the solution for our system of equations is 3, 5. It's an ordered pair, and so that's how we're going to write it. Okay, let's do another one. Like I said, we're just going to be working through a whole bunch of problems. So let's do another example. Here's our system. We have 2x plus y equals 3, and we have 4x plus 2y equals 12. So I need to solve for one of my equations. So if I look at my equations, I'm still going to just go with the top one. And it looks like my y is pretty much by itself, so I'm going to solve for that one. So I have 2x plus y equals 3. I just need to get the y by itself. So that'll give me y equals 3 minus 2x. Now I have to take this and plug it into my second equation. My second equation is the 4x plus 2y equals 12. So I figured out my y. So I need to plug that in anywhere there's a y. So that'll give me 4x plus 2 times 3 minus 2x equals 12. So I get 4x plus 6 minus 4x equals 12. My 4x's go away. 4x minus 4x is 0, so I'm left with 6 equals 12. Is that a true statement? No, that's false. So if you get to a point where it's false, that means that this is an inconsistent system, and there are no solutions. For the first example that we worked, we got a solution because it was a consistent system, and so that means we got 1 point. This one is an inconsistent system, so there's no solutions. We found something that was false. So that can happen. That's a totally valid answer. So we're going to need to work another example. Alright, let's do another one. Example. If you remember from 9.1, there was 3 types of systems. So you should expect to see all 3 on your homework and on your quiz. So we're going to work one of all 3 of these. Okay, so here's our system. We have x minus 1/2 y equals 2. And y equals 2x minus 4. Step 1 said we need to solve one of our equations for one of the variables. If you look at our second equation, it's already solved for a y. So we're just going to go ahead and go with that. We have y equals 2x minus 4. That means in our first equation, our x minus 1/2 y equals 2, anywhere there's a y, we need to plug in all of this stuff. So that would give us x minus 1/2 times 2x minus 4 equals 2. So x minus x plus 2 equals 2. Notice our x's will go away, So that leaves us with 2 equals 2. Is that true? That is true. So if you get to a point where all your variables go away, but you're left with a true statement, then this means that there are infinitely many solutions. This is a dependent system. Dependent system. So when you have a dependent system, you're going to be working through your problem and you're going to get to something that's always true. 2 always equals 2. So you have no more variables. That means you have infinitely many solutions. Those are the 3 types of answers that you can get when you're doing systems of equations. Alright, let's do one more example. Again, these are straight off of your homework, which is why I'm not going to be doing any actual homework problems with you today. So let's do a 3x plus 6y equals 9 and a 2x minus 3y equals 6. So we need to solve one of our equations for one of the variables. Again, if there's not a clear-cut one, I'm just going to go with the first one. So we have 3x plus 6y equals 9. I'm going to solve for my x. It does not matter. If you wanted to solve for your y, you could, and you're still going to get the right answer. Or if you wanted to do the second equation, you could totally do that. So there's really 4 ways you can do this problem, and it's all going to work out the right way as long as you're doing your math correctly. I usually go with the first one, and then I usually go with x or y. It just depends on if it's a nice answer, excuse me, nice number. But in this case, I'm just going to solve for my x. So if I have 3x equals 9 minus 6y, and divide all parts by 3, I'm left with 3 minus 2y. Now in my second equation, anywhere there's an x, I need to plug in all of this stuff. So that leaves me with 2 times 3 minus 2y minus 3y equals 6. So that gives me 6 minus 4y minus 3y equals 6. So I subtract over my 6 and I combine my like terms, so I'm left with negative 7y equals 0. So y equals 0. Now I have to take that and plug it into that first equation. So I have x equals 3 minus 2 times 0. So that equals 3. So my ordered pair, my solution for this system of equations will be the point 3, 0. I'm going to work the same problem, but I'm going to solve for y in that first case, just so you can see that it still works out. So I'm going to do this bottom one, and I'm going to solve for y. So this is the same problem. If you've got this and you want to just go ahead and quit watching the video, I understand. I just want to show you it does work out. So I'm going to take the 2x minus 3y equals 6, and I'm going to solve for my y. So I have 2x minus 6 equals 3y. Divide everything by 3. I get 2/3 x minus 2 equals y. So now I have to plug that into the first equation. Anywhere that there's a y, I have to plug all of this stuff in. So that leaves me with x plus 6 times 2 over 3 x minus 2 equals 9. So that gives me 3x plus 2 times 6 is 12, divided by 3 is 4x, minus 6 times 2 is 12 equals 9. So that'll give me 7x equals, I'm adding the 12, that'll give me 21. Divide both sides by 7, that'll give me x equals 3. So now I have to plug that into this part over here. So I have 2 over 3 times 3 minus 2 equals y. The 3's would cancel. That'd leave me with 2 minus 2 equals y. So 0 equals y. So my ordered pair would be 3, 0. It does not matter which you solve for. It does not matter at all how you do that. Notice I got the same answer working it both ways. So there's really no wrong way to approach this problem as long as you can keep track of your negatives and you're plugging, obviously you're plugging the right thing in. So good luck on your homework and good luck on your quizzes.